So for two questions, we're asked to simplify some. They're both monomials that involve powers, two powers, division, etc. So we're going to do both A and B. Let's start with A. And I wrote the problem over here separately so we can kind of take a look at it with a little bit more space. The first thing that I want to do is I'm going to choose to do this. There's multiple ways I can do this, but I'm going to take this portion of it and I'm going to raise each one of those factors inside to the third power. So if you look at it, that part that I've highlighted would become 3 to the third, A to the third, B to the third. And when I take c squared to the third, that's going to be c to the sixth power. So one of the things that might be helpful for you is if you don't see exponents, you might want to remind yourself that there's always an implied exponent of 1. So in each one of these cases, I'm multiplying 3 times 1, 3 times 1, 3 times 1, and then 3 times 2. So this part that is highlighted is what I've written below. And what I'm going to do with the other part is I'm going to go ahead and choose to write all of that down in the denominator. And when I do that, this negative 2 power will become positive 2. So notice the big difference here, right? Everything is going to be just as it was. I'm going to have an A and then times a B to the fourth times a C. But instead of being raised to the negative 2 power, since I've moved it to my denominator, it's going to be to the second power. So, and we've talked about exactly the mathematics that justifies this step, but at this point I'm just using that math. Now I'm going to do the same thing I did with the first part, right? I'm going to do the same thing with this denominator. So I'm just going to rewrite the numerator again carefully. So I've got 3 to the third, A to the third, B to the third, and C to the sixth power. And now in my denominator, I'm going to write in these exponents of 1. But look at what this becomes. This is going to become an A to the second, a B to the eighth power, and a C to the second power. And at this point, there's several giant ones that are lurking here, right? We can simplify this. And I can use that notation and write them out as giant ones, or we can use other techniques. I think I'm going to write them out. One thing I am going to do is my only numerical coefficient there is the 3 to the thirds, and there's nothing in the denominator to cancel with that. So I'm just going to write the number 27 at this point. And then you'll notice my denominator has A to the second, and it also has another one. It's got an A to the first because it was A to the third power. The reason why I'm writing it this way is because now you can see there's clearly a giant 1, right? I've got an A to the second over A to the second, and there's still one factor of A left over in the numerator. In my numerator, I have 3 factors of B, and in my denominator, I'm going to write that B to the 8th. I'm going to write it as B to the 3rd times B to the 5th power. So again, you can see there's this giant 1 of B to the 3rd over B to the 3rd. And then the final thing that we've got is this C to the 6th. So I'm going to rewrite that as C to the 2nd times C to the 4th power. And in my denominator, there was a C to the 2nd power. So again, there's a giant 1 here. So those are all equal to 1, the things that I've boxed. So they're not adding any new value to this expression. So my final answer, you can see, is in my numerator, I've got a 27 and an A and a C to the 4th power. And down in my denominator, I have a B to the 5th power. So it's one way to approach this. If you're looking at simplifying expressions with exponents or laws of exponents, either the Khan Academy or somewhere else on YouTube, feel free to find something that works for you and is producing correct solutions. This is the correct answer, and there's certain things you could do to tweak that answer, but largely this is not negotiable. So this is the simplified expression, simplified form of the expression that we started with. Let's go to part B. So for part B, I think I'm going to go ahead and do the same thing where I raise 5x squared to the second power. So that entire thing is being raised to the second power. That's where we're using these parentheses. Let me highlight that. So the only thing I'm going to change is this portion of it. So this will become a 5 squared times x to the 4th power over y, and I'm multiplying that by 3y to the 3rd over 5. And of course when we multiply a fraction times a fraction, right, it's numerator times numerator over denominator times denominator. So I'm just going to rearrange a couple things here. So I'm going to write this as 3 times 5 squared, and I could write it as 25, but there's a common factor of 5 I want to cancel out in a minute. Then I've got my x to the 4th, and I've got my y to the 3rd. Now the order of those is not necessarily critical, so it's very preferable to have your numerical parts out front like this, but if you were to exchange the y to the 3rd and x to the 4th, it would still be a correct answer. In my denominator, you can see I've got a 5 and a factor of y. So there are two giant ones here that we should eliminate. If I expand that top a bit, 3 times 5 times 5, in my denominator there is a factor of 5, so there's one of the giant ones. Then I've got an x to the 4th times a y times a y squared, right? That's what y cubed is. And you can see there was times another y in the denominator. So I just broke it out like that. So I can see that there's a common factor of y in both my numerator and denominator. So as I move through and simplify this, in my numerator I'm left with the number 15. I've also got an x to the 4th power, and I've got a y to the 2nd power. So this is the simplified version of that original expression. That's the end of question 6.